Good morning, everyone. As I mentioned yesterday on our Zoom call, that there will not be a Zoom call today. So I wanted to put out a little quick video of what my expectations are for today. So today you will be watching this video as you're doing right now. There is a assignment for you to complete, and you can either complete the assignment by printing it out and filling it out and taking a picture and then sending it to me, or which you can send to me right into Google Classroom, or you may write directly on or you may type directly on the document and turn it into Google Classroom. Either way is perfectly acceptable, and so whatever you feel more comfortable with. So today we have been working all week. We've been practicing and reviewing weather and atmosphere. We've been practicing our vocab words with Edpuzzle and with Gimkit. I'm sorry, not Edpuzzle, quizzes and Gimkit. And so this is the standard that we have been working with. So it's compare the composition, properties, and structure of Earth's atmosphere to include mixtures of gases and differences in temperature and pressure within the layers. So this was the very first standard that we did way back in August or September. And so we're just starting to kind of review some of these concepts so that we can show that we have our mastery. So first thing you're going to do is, if you notice on the worksheet, there are 4 warm-up questions for you to do. So let me show you. They are, oh, let me get this up here. Oh, that's not what I wanted. Here it is. So there are 4 warm-up questions. So 1, 2, 3, 4. Like I said, if you are writing directly on the document, you can highlight. If you are printing it out and writing, you can just circle the answer. So there are 4 questions here. Later on today, I will post the answers to those 4 questions, or later on, I'm probably tomorrow, I'll post the answer to those 4 questions. Then the rest of this PowerPoint is the review it section. So I'm going to be going through, you're going to fill out the blanks. Like I said, you can either type directly in, or you can print it out and write on it. The last piece is the apply it. So the information that you're talking about up here, you're going to apply it to answer these questions here. So make sure you're using complete sentences, and then you can answer it right in these boxes. If you need more room, go ahead and add another piece of paper or on the back, or if you're just typing in here, it'll just go on to the next page. All right, so let's get back to our PowerPoint. So you completed the warm-up questions. So reminder that the atmosphere is a mixture of gases that surround the Earth, and that we have 3 sets of gases that make up. So nitrogen makes up that 78%. Oxygen, what we breathe, makes up 21%. And carbon dioxide and argon together make up 1%. So in our atmosphere, we have layers of the atmosphere. The atmosphere is broken up into 5 different layers. They are separated by temperature, altitude, and air pressure. So remember, the higher you go, the lower the air pressure. As altitude increases, air pressure decreases. And then remember, in temperature, it depends on the layer, on where is closest to the sun, how far from the sun, what kind of energy is getting put into that layer. So in the troposphere, though, remember, that was the important one. In the troposphere, which is the lowest layer of the Earth, as altitude increases, air pressure decreases. So just a real quick reminder and a way to remember the layers of the atmosphere. So starting from the Earth, we have troposphere, stratosphere, mesosphere, thermosphere, exosphere. And remember, those by tropical Skittles are mighty tasty to eat. So, a little bit information about the individual layers. The troposphere, this is where weather happens. We live in the troposphere. So, this is when you look up in the sky, you are seeing the troposphere. Ozone in the troposphere is known as pollution. Okay, we'll get to where ozone is good, but ozone in the troposphere is pollution. So clouds are here. Most airplanes fly here. Um, we've got Mount Everest that we've talked about, different clouds, the water, the ground. That is all in the troposphere. Now, as we move up, we get into the stratosphere. So this layer contains our ozone layer. And ozone is a gas that absorbs UV rays and it protects us from solar radiation. Remember, if we did not have the ozone, we would all be fried crispy. So that ozone layer absorbs the UV rays so that it protects us from the radiation of the sun. Because of this, temperatures rise because of the UV ray absorption. So just think of it like a towel out on a piece of or a concrete on a hot day. It's going to absorb those rays and eventually it's going to get warm. So when you sit down or you pick it up, it's warm. So because of that, the temperature rises in the stratosphere. So the mesosphere, then we're going up to the next layer. So we've got the troposphere here, the stratosphere is next, and then we have the mesosphere. And this is the coldest place that you could ever think of. It is colder than anything that any human could survive. And this is where meteors burn up. Well, how does that happen? Well, meteors burn up here because it is so cold. And if you remember, a meteoroid is a rock that's basically on fire. It's traveling through space, it's on fire, so you get the extreme temperatures and the rock breaks up. So that's what helps keep us safe from meteors that are out in space because of the mesosphere. Thermosphere. So the thermospheres, we have the troposphere, the stratosphere, the mesosphere, and now the thermosphere. And the thermosphere is the layer that contains the northern lights because it is made up of electrically charged particles. So all of these particles are bouncing around in the thermosphere and the light is reflecting off of them. And it shows these greens and blues and reds and purples. And it's really, really pretty. And you can see it when you're at high altitudes. So things like in Alaska and Russia, Antarctica, that's where you can see the northern lights. So the thermosphere, though, because of these electrically charged particles and they give off so much heat, that the thermosphere is actually the hottest layer. So we've got in the troposphere, the temperature the temperature falls as altitude rises. So altitude goes up, temperature falls. In the stratosphere, as you go up in altitude, the temperature goes up. The mesosphere, as you go up in the mesosphere, the temperature goes down. And the thermosphere, as you go up in the thermosphere, the temperature increases. And then finally, we have the exosphere, and this is the highest layer, and it kind of flows into outer space. So the highest layer of the atmosphere, this is where satellites are. So all the satellites that are working with our cell phones, our computers, our internet, our TV streaming, all those satellites, Google Earth, Google Vision, all that stuff, they're all done by satellites. And those satellites sit up in the exosphere, and then they radiate waves down to Earth. So we've been talking a lot about air pressure. And so air pressure is the weight of the atmosphere that's pressing down on Earth. So air presses down on you. Okay, it's very light, so we don't always feel it. But think about when you go to the bottom of a pool. You can feel the pressure at the bottom of the pool where you don't necessarily feel it as much at the surface of the pool. Same thing with air pressure. So high air pressure, those molecules are very close together. And low air pressure is those molecules are further apart. So closer to the center of the earth on our ground and everything else, those molecules are really tight together. There's lots of pressure. As you go up in altitude, and even as you go up through our atmosphere, the molecules start spreading apart. And so there is less air pressure. So altitude, remember, is the height of an object. So the top of the mountain is high altitude. The air, as you move up in altitude, is less dense. So there's less pressure, and so there's not as many molecules, and so it's less dense, which makes it hard to breathe. That's why you see people that climb mountains, they have to have an air mask on so that they can breathe. So as altitude increases, air pressure decreases, and temperatures change throughout the layers based on sun's rays. In the troposphere, as altitude increases, temperature decreases. Okay, so now there's that the last part of the section, that third part, where you're going to complete the apply it questions. So make sure that you do those, and then you can either turn it in, or like I said, you can turn it in on Google Classroom, or you can print it out, write it out on hand, and then take a picture of it and upload it to Google Classroom. So if you have any questions, don't hesitate to email me. I will be available for all of you. And I hope you guys have a good rest of the day and a good weekend. Remember, we have a Zoom call Monday morning at 11 a.m.